So this is the mechanics homework booklet question 10. We're asked first of all to define the moment of a force about a point, and it's the force multiplied by the perpendicular distance from that point to the line of action of the force, from the line of action of the force to the point we're taking moments about. Now on the new specification, the questions in the exam won't be specifically asking you for definitions, but understanding what these words mean clearly is very, very important, otherwise you simply can't use them. In part B, we're showing this system, shown in the diagram below. We've got a uniform rod CD, and if we look at that carefully, I've got 1.2 meters and another 0.2 meters, so it's a total of 1.4 meters long. Suspended by two lengths of string at A and B, I've marked on the tensions in those two strings, those two forces. And we've got a ball 3 newtons weight is attached to the rod in that position shown. First of all, we're asked to accurately draw onto the diagram an arrow to represent the weight of the rod. It should start at the centre of mass of the rod. It should go straight down, and I think it's worth labelling up the size of that 15 newtons. That is, with the whole rod being 1.4 metres long, that is 0.7 metres away from the two ends. X is the point at which string A is attached to the rod, and we're asked to take moments about X, so it's important that we do it taking moments about the point we're told to, if we're given one to do, determine the tension in the string at B. So that's TB by my notation, by the arrow that I've added on. So we're taking moments around this point here, and what have I got? Well, trying to turn clockwise, I've got the 15 newtons. That's 0.7 a metre from the end. The string is 0.5 a metre from that same end, so the distance between them is 0.2. And that's trying to turn in the clockwise direction. In trying to turn it in the anti-clockwise direction, I've got two forces. I've got the 3 newtons there, and I've got TB, the thing I'm trying to find there. TB, whole thing's 1.4 metres. If that's 0.5, that must be 0.9 metres. That whole distance is 0.9 metres. So there's TB times 0.9, and that is added to the moment due to the 3 newton weight. So there's the 3 newtons with that point that I'm taking moments about being 0.5 a metre away from NC, with the weight being 0.2 of a metre. The distance between the two is 0.3 of a metre away. So if I take that down, I've got 3 newton meters is 9 TB newton meters plus 0.9 newton meters. Taking 0.9 for both sides leaves me with this, and therefore TB is 2.3 newtons. We're then next asked to determine the tension in string A, so that's the force as I've labelled it TA. Very straightforwardly here, when you're left with only one unknown force, you don't need to mess around with moments. Once you've only got one force you don't know, you can simply do the sum of the forces in each direction being the same. So I've got TA plus TB is 15 plus 3, so I've got 2.3, which was TB we've just worked out, plus TA, the sum of the upward forces, is equal to the sum of the weights for some of the downward forces, and that gives me 18, take 2.3, 15.7 to the nearest newton to two significant figures. This relevant thing here is 16 newtons. So that's the mechanics homework booklet question 10.